Today, we see change all around us, and we don't know if that change is due to our impact or whether it's due to Mother Nature herself. In the past, it's all Mother Nature, and we get to listen to the Earth's rhythms and its beats like the rhythms and beats of a song. If you listen to the rhythms and beats, you can pick up a distortion like that. And it's that distortion, if it exists, is our distortion.
It gives you a deeper sense of what the world is like all around you, how it works. It's a little bit like music, you know, you can listen to music or you can listen critically and understand music. It gives you a deeper appreciation and a deeper enjoyment.
Well, I have a passion for understanding mountains. I'm not a religious person, but some people say that the high mountains are the closest you can get to God. I picked the study of ancient volcanoes near Louisbourg in Cape Breton, and walking along the coastline there, being able to look at the site of ancient volcanoes 550 to 600 million years old, and realizing that they were part of another continent back then. Well, we didn't know exactly what continent it was, but now we think it's South America. That led me to believe that this was important work to do and incredibly exciting and challenging.
Science is like a pyramid. We've been doing science for 2,000 years, and there's a lot of stuff to learn before you get to the place where you're starting to do your own original work, where we're looking at all of the different kinds of remote sensing technology that are available today to get a snapshot view of the ocean so that we can figure out what the underwater acoustic environment is all about. And that's really challenging in a lot of ways because, you know, satellites don't actually see underwater. They just see the surface. They see the surface temperature. They see the surface roughness. They see the height of the surface, but they don't really see underwater. So there's a big disconnect between what you can see from space and the information that we're looking for about how sound travels underwater.
I myself have tried to write general articles in either encyclopedias or in media like Scientific American and American Scientist, which are accessible to the interested civilian.
Some of the things I've done in science communication involve science fairs and talking to classrooms about some of the research work I've done, talking to teachers. I've done work with the Discovery Channel explaining, you know, everyday optics.
I think scientists are very privileged. We get to work on things that we're very interested in. I believe we have a large responsibility to communicate the essence of our findings.
How does the public come to appreciate that? I think that's the job of the science communicator. They know what the important points are, and they know the real, you know, the nucleus of the research and what is important to people and what's exciting too.
We all walk around our planet, we all look at these beautiful streams and these beautiful settings, but not too many of us really understand how this came about.
I look around me at the trees and the leaves and, you know, look at the sky and realize what a beautiful blue color it is, and I understand something about the optics that creates that. It might be boring to some people, but to me it actually makes me have a deeper sense of, you know, connection with the natural world.